Hello students, good morning to all. I hope you all are fine. Students, as you know very well, we have started Unit 5 Thermodynamics. So today we will continue this unit, and today we will discuss about some basic terms of thermodynamics. Okay. So first one is the microscopic system and macroscopic system. Students, microscopic system is that in which individual particle is taken in consideration, or we can say that in which we take individual particle, individual molecule under observation. Okay, but students, you know, in thermodynamics basically we will do work on the macroscopic particles. Okay, we will not do work for microscopic. Individual particles we cannot consider it basically in thermodynamics. Okay, because in thermodynamics we discuss about the temperature, pressure, volume of a system, and temperature, pressure, volume, these cannot be considered for an individual particles. Clear or not? So what do you mean by the macroscopic system? Macroscopic system, the system in which individual macroscopic particle, what happened beta? Macroscopic system is that in which individual molecule is not considered, but we will consider average property of all the molecules. Clear or not? But we consider average property of all the molecules. For example, students, if I want to if we want to calculate temperature, means for an individual particle we cannot calculate. We can calculate in bulk. So it is macroscopic system. Clear or not? Basically thermodynamics work on the macroscopic system, not on microscopic. Clear or not, students? Yes. So some more terms we will discuss today. Extensive property. Extensive property. What do you mean by the extensive properties? Extensive properties are those in which whose value depends on quantity or size of matter present in the system. Extensive properties are those properties whose value depends upon the quantity or size of matter present in the system. For example, students, if I am having a piece of metal, or we can say I am taking a metal sheet. This is metal sheet. Let us consider its mass is m. Its mass is m. Clear or not? But students, if I divide this sheet into equal halves, then what will happen? Now mass of this will be m by 2. and mass of this will be m by 2. Clear or not? So here mass of this sheet is depending, mass of this sheet is depending on the quantity, on the quantity of the matter present in it, because if it is becoming half, then its mass is also becoming half. Clear or not? So mass is the extensive property. Volume is also, volume is volume, internal energy. We will discuss about that, what is internal energy, etc. Volume also extensive property. What is volume? Volume is the space occupied. Okay. So students, here let us consider this volume is V, but the space occupied by half of this sheet will be half of this volume, and it will be V by 2, and it will be V by 2. Means it is depending on the quantity of the matter present in the system. So mass, volume, internal energy. Okay, these examples are the examples of the extensive properties. And extensive properties are those properties whose value depend upon on the quantity or size of matter present in the system. It is clear to you or not? Any doubt in this? Yes. It is also known as the extrinsic property. It is also known as. Then students, next one is the intensive property. Intensive property or intrinsic property, we can say also. So just opposite to this, whose values do not depend on quantity or size of the matter present in the system. Present in the system means whose values do not depend on the quantity or size of the matter present in the system. For example, students, temperature, pressure, density, students, for example, again we are taking piece of a metal sheet. And let us consider this metal sheet is hot. This metal sheet is hot. Then student, let us consider its temperature is T. Its temperature is T. Let us consider T is, we can consider 50 degrees Celsius or we can consider 50 Kelvin. Depend on us. Okay, we are considering. If I divide this sheet into halves, Okay, and if you touch this seat, only this part of the seat, only this part, okay, then can you consider that it will be cooler as compared to this? Can you consider that? No. Means if this total has temperature 50 degree, so its temperature after doing half also, its temperature remains 50 degrees Celsius, and its temperature also remain 50 degree Celsius. Clear or not? It is not reducing. We cannot say, ma'am, after becoming half, it is having temperature 25 degrees Celsius, now it becomes cool and now we can touch it. Okay, so and it is having 25 and total they are having 50 degree. No, each particle temperature will be same there. Clear or not? Yes. So this one is example of the intensive property. Intensive properties do not depend on the quantity or size of the matter. They do not depend on quantity or size of the matter. It is clear to you or not? Any doubt? Yes. Then students, the ratio of two extensive property is always intensive. You will keep in mind. For example, I have given example. Mass. Mass is extensive property. Volume. Volume is also extensive property. But students, you know very well. Density. Density is mass per unit volume. Density is mass per unit volume. So it is the ratio of two extensive properties. But density itself is intensive property. It is intensive. So ratio of two extensive property, we get intensive property. It is clear to you or not? Yes. Students, now we will discuss about the thermodynamic equilibrium. Before that, we will discuss about some processes, thermodynamics processes. First one is isothermal. Isothermal process. Isothermal process is that process in which change in temperature is zero. Means temperature of system and surrounding surroundings is same. Then total change in temperature will be zero. Then this type of the process is known as the isothermal process. Delta T will be the zero. Delta T will be zero. Clear or not? Next one is the adiabatic. Adiabatic process. Adiabatic process is that process in which change in heat or change is energy is zero. Or we can say if heat transfer does not take place, neither heat transfer from system to surrounding nor heat transfer from surrounding to system. Okay, if you are taking water in a glass at, let us consider this has temperature 28 degrees Celsius. Clear? But students, when you are keeping this water container in freezer, then it is absorbing. This is system because we are observing this one. So it is taking heat. It is absorbing energy. Clear or not? And it becomes cool. It's become cool and it convert into the ice. Means it is absorbing the energy. It is absorbing the energy. Sometime if we are taking hot water and we keep it in atmosphere, okay, then it become cool after some time, means it is releasing amount of energy, it releasing some amount of energy. But in thermos flask, you know very well, water remain as it is. At what temperature we are taking? At the same temperature for a long time. At the same temperature for a long time. Why it is? Because here walls of this are adiabatic. Adiabatic. Here system, here heat is not entering from surrounding to system and not coming outside from system to surrounding. Clear or not? Means no transfer of energy is taking place here. So total change in energy, it is zero. Delta H is equal to zero. And that type of process is known as the adiabatic process. Then isobaric process. Isobaric means total change in pressure. Here no change in pressure take place between system and surrounding, means change in pressure is zero. Then isochoric. In case of isochoric process, change in volume is zero. Means neither work is done on the system nor work done by the system. For example, students, yes, for example, here we are taking some matter in this, and students, here we are applying some pressure on it, on surface of this. We are applying some pressure. Then what will be happen? Means if we will apply some pressure on that, so these particles will come closer, and their volume get reduced. Means change in volume is taking place here because we are doing work, we are applying pressure on this. We are applying, means from outside we are doing work now. So that is known as work is done on the system. Work is done on system. But sometime, if already these particles have more kinetic energy, okay, and they are moving, and this piston comes outside, means here this system is doing work, and it is known as the work is done by the system. Work is done by the system. So students, here change in volume take place. Either work is done on the system or work is done by the system. But in isochoric process, change in volume is zero. It shows that neither work is done on the system nor work is done by the system. It is clear to you or not? Yes. In isothermal, I have already discussed change in temperature is equal to 0. So you will keep in mind some other processes are also there, but basically we will work on that. Clear or not? Basically we will work on that. Some other are also there. Ice, enthalpic, entropic. Okay, in this change in enthalpy will be 0, change in entropy will be 0. What do you mean by enthalpy and entropy? We will discuss later in this unit also. Okay, so here if change in energy 0, it is adiabatic process. If change in pressure 0, it is isobaric. If change in volume 0, it is isochoric. If change in temperature 0, it is isothermal. Okay, all points are clear to you. So thank you. Have a nice day.